Draw the single line diagram team again. 1, 2, 3, 4, and 5. These are the 533 kV feeders connecting to a bus, and I am having a transformer here. Okay, and this transformer, let's see this case, including the metering at this position. 1, 2, 3, 4, 5, and these are connected to this. Okay, let's see this in this way. Suppose we here assume I'm having 2 meters. So this is connecting to a meter 1. This is the metering system. And this is the having again a meter. This is the metering system. And these 2 metering systems are connected to a bus. I am developing the single line diagrams in this way because one and of double in the 33 kV we decided single bus bar with sectionalizer, right? So I am making this here, and from here connecting to the transformers. And from this transformer is connecting to again a metering. Meter in the sense both. I already told you both. And this is connecting to the double bus bar configuration. And this is the coupler. And 2 lines are going out, right? So I am considering the lines in this way, right? Because I am not having the space. That's why I'm considering like this again. This is the one line going out. And this is the one more line going out. Till now, clear team? This is the again a meter. Understood team? Are you comfortable of understanding this? How we developed this? Okay, fine. Good. Domestic consumers also. TOD in the sense?
Time of the day.
Time of?
Time of day. Day. As you told, no, during peak hours, tariff will be more. During night time.
Domestic consumers in the sense? For the households, huh?
For houses, yeah.
It is actually there. The time of the day is not there. Generally, this here, what they will do is they will rise the rates if the units are generated more. That we are seeing, right? Suppose.
Yeah, that we know. Yeah.
That is the only thing. Time of day not there.
Okay. This is for industrial, right?
Yes, industries.
Okay.
Now, so now I am adding the equipments for my SLD team. Okay, let's see what I told. Starting of my substation, we are having the lightning arrestor, and ending of my substation having the lightning arrestor. This already we know. And also I told the lightning arresters to be placed on either side of the transformer also. Right? So these are all my lightning arresters. And similarly for this, I'm not drawing this because same all. Okay. Now, and the next what I told, for every feeder at every bay, at every stage, we have to consider as a bay. So to protect this bay, we required breaker. If you want to give the breaker here also, you can give, Mostly for 33 kV, again for the metering, breaker is not required because you can't see the any failure in this mostly. It is only a meter, right? So not required. And for the sectionalizer, we require the breaker. And for the either side of the transformers, for the protection of the transformer, we require the breaker. And after the transformer, we require the breaker. And in the 220 kV, for this double bus bar protection, everything, we require a breaker. And the bus coupler, we require a breaker. And for the lines, we are having the breaker. We require the breaker. Right, team? Now, who will, so for this breaker, you required, what you be required? A current and voltage inputs to be given to the relay. So relay will give the command to the breaker to open. So we need a current transformers also. So let's see, current transformers you can place wherever you want him on either side of the breaker. Again, in some cases, it will be different. I will tell when I'm explaining about the protection class. So for this breaker to monitor, we required a current transformer. And here also we required a current transformer. Current transformer. Current transformer. And for the here also a current transformer for the microphone. And for this maintenance, I require the isolators. On either side of the breaker and CTs, we are having the isolators. Because if I want to attend the maintenance, I will open these two isolators and I will do the maintenance, right? So isolators, all the isolators. Now, if I want to take out this meter and I want to do the maintenance, for the maintenance purpose, I require isolators here. And to isolate this, I require the isolator. And for this maintenance, isolators. This is single, so I require only two isolators we can manage. With the two isolators, we can manage. Because whole single, right? See, if I am attending the maintenance for this, I have to open this. Why again duplication of the isolators? Not required. Isolator. Now here, and I want to I want to energize maybe this bus or this bus. So two isolators are required when you are connecting to the double bus. Isolators, and line side isolators, because to may attend the maintenance again. Right? So again, to discharge the energy static electricity present in the line, we require edge switches. Edge switches you can place for every isolator team because it's totally depends upon your requirement. But generally, we will place on the line side mostly. In the other parts, not required mostly. In other cases, if you want to discharge, you can lay a portable edge switches and you can do the maintenance. You can attend the maintenance up to 220 kV. Above that, you have to give the isolator edge switches for every isolator also. Fine. Now, come to we left with the PT, right? So potential transform also we have to add. But here, let's see team. If you check here, the current will differ at every node. But up to here, the potential, the voltage will be 33 kV only, right? At every part below this transformer. The current will differ. Maybe here I amps, here I1, here I2, maybe differ. But the current, but the voltage always 33 kV, 33 at every stage should be 33 kV, right? And here always it should be 220 kV. So for an optimization, not required to place the potential transformers on the lines or in the feeders unless if you are synchronization, unless you want to synchronize the generator with the grid. Unless I will talk. So generally all the substations having the potential transformers and the buses. every bus, wherever the bus is there, you have to place the potential transformer. For all the buses, we are having the bus PTs. This is the bus required bus PT 220 kV. This is the bus required bus PT 220 kV. And this is also a bus requires a bus PT. And again, to attend the maintenance of the bus, we require isolator, 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 and isolator. Now, generally in the wind farms, in the wind generations, the synchronization will be happened at 690 volts at the wind turbine. And if you see the generating like hydro plants, the generating this is connecting directly to the generator. This is directly connecting to the generator. So in those cases, you require the potential transformers. In the renewable projects, you not require the potential transformer in the 33 kV level. But we need a potential transformer on the 220 kV level only to know whether the voltage has come up in my substation during the commissioning stage. During the commissioning stage, just checking the voltage. Suppose now I want to synchronize the wind turbines to the grid. Now, how to do that? I have to back charge. Means I am taking some power to the generator to the up to the WTG wind turbine generator. So wind turbine generator will see the reactive power, active power, and based on that, it will generate the power. So from then, the wind will generate the power. So first starting, you have to take the power from the grid to the generator. So for when you're doing that, these are the power is coming through this. So you have to know whether the voltage has come up or not. So if the voltage is appeared, then you are closing this breaker. So for the checking, you required a potential transformer here. So I required a potential transformer here. And suppose if this project is the communication, we are having a communication for substation to substation. Suppose a fault occurred in my substation, and if I want to tell the same to the connected substation, there is a fault in my substation. Could you please open up the breakers? So there should be some communication between the two stations. If you are adopting this communication through fiber optic telecommunication, this can be done with the two types of communications. One is PLCC, power line carrier communication, PLCC. Other one is fiber optic equipment, fiber optic telecommunication, FOTE cable through OPGW wires. Two type of communications are there. If in the old projects, we are having PLCC, which is power line carrier communication. This power line carrier communication, we are sending the signals with a high frequency bandwidth with the same lines using wave traps. When I'm talking about the PLCC. So this wave traps required on this way with the help of these wave traps, and you have to for this communication, you have to have a higher bandwidth and high frequency signal that can be achieved by CVT, capacitive voltage transformer. So instead of placing the potential transformer, they are having capacitive voltage transformer, which is CVT, which can do the two activities of, one is the measuring the voltage, other one for the communication. So if your project is PLCC, you have to go for CVT here and a wave trap here for one phase. That is a one case. But present, none of the projects having this type of PLCC communication, all going with the FOT, fiber optic telecommunication, which is easy and reliable communication as per IEC 61850 protocols. So you are going, you have to you need only for this, you not require the CVT and wave traps. So you can place directly a potential transformers on the lines. But in 220 kV, from 220 kV and above, the potential transformer cost will be high compared to the CVT. The CVT cost is less, above or equal to 220 kV because of insulation. Because of insulation, the voltage is related to the insulation, right? So if the voltage is high, you have to give a good insulation. Insulation cost will be high. So above 220 kV, instead of potential transformers, they are placing capacitive voltage transformers only. So for the lines, so you can see, you can place a potential transformer also. So at present, to avoid for a cost optimization, you are having the CVTs on the line ends. So this is the CVTs on the board. These are the bus potential transformers. If you see the 220 kV, 400 kV, the bus PTs are also CVTs only, capacitive voltage transformers. So this is the actual the requirement of CVT for the PLCC and FOT. So we should have the potential transformer at the line. It could be a CVT or it could be a PT, whatever it may be. So now the system you developed. The one thing was left is, for all the system, you need a auxiliary supply. You have to provide the auxiliary supply for the breaker opening, for the isolator opening, for the transformer fans, everything. So how can yes, CVT and PT, the explanation, the concept I will tell when I'm explaining about the CVT and PT, but just I'm giving a simple difference. The capacitive voltage transformer works under the principle of capacitor voltage divider principle. Voltage divider principle. The circuit will be like this. So it is working at the voltage divider principle. So if I am going for high voltages, CVT cost will be low because of no insulation. Not required much insulation here. If you see our PTs, those work on the principle of mutual induction. So total 198 kV, 198 kV means 220 by root 3 phase to earth voltage is appear on in the phase. So I have to provide the insulation for whole this 198 kV, which cost me more. So we are not required this capacitive insulation. For this reason, we are going with a CVTs for high voltage transformers and the PTs for the low voltage cases in the low voltage applications. Up to 220 kV, you can see PTs. Above, you can see only the CVTs because cost is less compared to the PTs. Can you explain the PT breaker?
For low voltage cases also, can we use CVT?
Cost is very high. Capacitor cost is high. Yes. Can you explain PT breaker upper side and CT breaker down side? What is that CT breaker upper side? I'm not able to understand the question.
Hello.
Yeah. Yes.
Sir, breakers जो है VCB breaker या SF6. So PT is upper side installed and CT is single line diagrams. PT is upper side and PT is upper side and CT down breaker downside. How to explain, sir?
You mean here, this is upper side of the breaker. Huh?
Yes, yes, yes. Yes, sir. Yes,
See,
sir.
PT is always to be placed on the buses. Here, to know the voltage signal by seeing the voltage signal to close the breaker, I have to place this PT before the breaker. So always the PT should be at the first when you are synchronizing, because by seeing the voltage signal, suppose this is the PT, by seeing the voltage signal, you are closing the breaker. If you place the brake after the here, how this breaker is open. So how can this PT can see the voltage is appeared or not, right? So in this case, always the PT will be in the upper side of the breaker. Okay. And come to
Okay,
the seat.
matlab,
Yeah.
okay, matlab, sir, sorry. PT is installed first upper side because the under voltage fine now.
Yes, sir. If there is an
Voltage,
under
voltage.
voltage or voltage not you are not receiving, so you will not close the breaker.
Okay, okay, sir. So under voltage receives and voltage मतलब voltage ज्यादा आ गया तो की जैसे ब्रेकर ट्रिप भी कर सकता है और सीटी को कमांड मिलता है मतलब
Okay.
ऐसा ही है ना सर?
Yes, yes, yes.
Okay, sir. Thank you so much, sir. Please, can you explain, sir?
Yes, sir. And come to the CT. CT is generally you can place on the either side of the breaker, but you have to maintain the star protection, means earthing of the neutral of the CT. So that this I will tell when I'm explaining the control and protection schematics. There it will come. And why in some cases CTs to be placed on the line side is maybe you can understand or not. I will just clear you this. I will repeat this in the control protection just for a example to give an idea. I'm telling. Suppose the breaker is in open condition. Now I closed the breaker here. So now I don't know. There is some fault here. There is some fault here. Okay, fault happened. So if the CT is placed after the breaker, then how can the CT will detect the fault? No, right? And it's and if you are closing the breaker, it will means the person who is standing and manually operating, or when you are closing the breaker in the fault condition, it will create a damage to the nearby equipment. So in this case, and that we will call as a end fault in the distance protection scheme, we will call as an end fault. So to avoid this condition, we are placing the CT before. So if any fault occurred between the CT and the breaker, so the CT is sensing the fault and if it is a zone 2 fault for the upstream breaker, so it will give the command to the bus bar differential protection. All the breakers which are connected to the bus will be opened up. So I will talk this in the distance scheme. It will not, you will not, I think maybe you are not able to understand or not. I will talk about the CT's position in the control and protection chapter. For time being, let's assume the CT can be placed on either side of the breaker. Fine. So for this auxiliary consumption, for the breaker closing or opening, for isolator closing or opening, for the transformers switching, fans, and for the whole system illumination, you require some auxiliary supply. 33 kV is the supply here. 220 kV is the one more supply. So how can we get 415 volt supply, which is the voltage required for the lights, fans, and motors? So you have to have one more transformer, which is stepping down the 33 kV voltage to 415 volts. So this is again connecting to this way. Similarly, here also I am having one more transformer. Again, why I am having two transformers? As per the reliability. If one of the transformer is failed, other will be there. How can you know that we need two transformers or more? That we can study from the reliability that we are seeing in our next classes. So for this isolation, again isolators. I said before the transformer, we required lightning arrestor. Lightning arrestor to be there. Lightning arrestor is there. And now, mostly this, in the 33 bar 220 kV substation, mostly the load will be 250 kilowatt, mostly maximum 250 kilowatt or less than this, the auxiliary consumption load. So for 250 kVA transformer, for 250 kVA, what would be the current in 33 kV? Just calculate what would be the current in 33 kV. Let me show you. Let's see, for 220 kV system, 220, what is the one? 250 kVA. If I am converting the current divided by 1.732 into 33 kVA, no need of power factor. So what is the current? 5 amps current. Only the 5 amps current in 33 kV. So in the market, we have to check whether the 33 kV, in 33 kV 5 amp CT is available. Nowhere the 5 amp CT is available in the market. And the breaker is also very 5 amps breaker is not also not there, 33 kV. And yesterday I already talked on this. My auxiliary transformer costs me a 4 or 5 lakhs or maybe less than this. So for this, placing of the breaker and adding the protection, so whole this, it's not a viable one because my capital cost is X, but I am placing the protection which is nearly 70% of the X. It's not a good. It should be less than 20%. So in this case, by checking that into the thing, and also other conditions like the market availability of the CT and the breaker, for the auxiliary transformer, we will not having the CT, we are giving the protection through the HG fuse. HG fuse, horn gap fuse. We will select the HG fuse based on the rated current. So based on this, we will trip the, this fuse will melt. So the protection for the auxiliary transformer is the HG fuse, 33 kV. And now this 415 volts is connecting to the main lightning distribution board or main AC distribution board that we are seeing in our module 3 AC distribution network. That is the next topic. So we are having the HG fuse for the as a protection for my auxiliary transformer. So by this, I completed my single line diagram. So all the equipments, everything was framed, everything was completed. So the next one is I have to give the designation to this each and every equipment, because when I am sitting in after for commissioning of the substation, when I am sitting in front of the computer and I want to operate the breaker or breaker or isolator of one to take that into the maintenance, how shall I know if I want to take this into the maintenance on tomorrow, then how can I open this? So I have to name this. So I have to give this some supply to that to open by clicking on this, by sitting in front of the system, by just clicking on the isolator open, then it has to open. This isolator should be open. So how can I know this isolator? So I have to name this isolator, and also each and every equipment in the substation to be named. So that is the representation of the single line diagram. That can be done. Generally, this is my way of design. You can design, you can have designation on your own. And my projects, what I will generally consider is A letter I will consider for 400 kV. B letter I will consider for that 220 kV. C letter for 132 kV, D letter for 33 kV. Just it's my representation team. You can have a D letter for 400 kV or 1, 2, 3, 4, whatever it may be. You can choose. So I am considering B and D. And each breaker, wherever the breaker is there, I will consider this as a one feed, each as a one feeder. A breaker, this we will call as a feeder or a bay. We will call as a breaker. Wherever is the breaker, we will talk that as a bay or a feeder. So in the 33 kV, how many bays are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this is not a bay because no breaker. 10, 11, 12, 13. So 13 feeders are there in my 33 kV. And in 220 kV, 1, 2, 3, 4, 5, 6. 6 bays in the 220 kV. Bay feeder represents a breaker, a breaker, CT, everything. Okay, team. Now I am giving the designation to the each one. I am first of all, I am giving the number to each feeder. I am calling it as a feeder 1, feeder 2, feeder 3, feeder 4, feeder 5, feeder 6, feeder 7, feeder 8, feeder 9, feeder 10, 11, 12, 13. So this is the lightning arrestor. LA isolator, what I told, 89 isolator, CT breaker 52 and again 89. Okay. Now and the edge switch 57. Now this is a 33 kV. So I'm giving the number D. What feeder? 1. So D1 lightning arrestor, D1 89A, 89, D1 57, D1 CT, D1 52, D1 89. Again, I am having two D1 89A. So to differentiate this, I am taking from the bus end, I am calling it as a 89A and I am calling it as a 89B. So whatever the switch associated with this, I am giving the same number to this 57B. And similarly, if I am doing for the line, suppose if I am talking about the feeder 1 in the 220 kV, then B1 LA, B1 CVT, B1 89, B1 57, B1 CT, B1 52, B1 89, B1 89. So again, 89A, B, and I'm calling this as a C. So associated with C. So this is B1. This is B2 LA, BT. This is B3, B4, B5. Understood, team? Am I clear on the representation? So this is the my representation.
Regarding this representation, I think this AB for base side A or line side B, is there any fixed means any standard is there or
no, you can choose. You can choose. You can choose 89A, 57A, and this is 89B.
Okay, but the rest of this 89, 52, and this 57, this one will be as per standard.
Yes. 89 89 means isolator. It's ANSI code. 52 breaker. And 57 because if I am writing isolator, it's a big thing, and I cannot give all these big names in my control and in control schematics. So I have to represent with some ANSI codes. So 89 means it's isolator.
Means in throughout the India, wherever maybe it will
not only India, global.
Okay, wherever maybe it mentioned 89 means it will represent for isolator only.
Yes.
Right?
Yes. So this is a representation of my single line diagram. So now I will show you. Give me a minute. So any doubts? Meanwhile, you can ask. So this is my single line diagram. All my 33 kV feeders. This is my meterings. These are my sectionalizer, transformers connecting to a single bus, and again a meter connected to a double bus bar. These are the couplers, and these are the two lines going out. And for every bus, we are having the bus PTs. Everywhere we are having the bus PTs. And this is the auxiliary transformer connected to the HG fuse. And this is the representation like D1LA, D189B, 57D, D1CT, D152, D189A. And always in the CTs, we are having the polarities P1, P2 team. Generally, what we will stand for, we generally represent is always P1 should be towards the bus. This is the practice generally followed in every every developer or utility. P1 should always focus on this side. You can see here, same CT, AC. This is the bus, right? That's why it's focusing P1 to this. Here, this CT, the P1 focusing this. Similarly. Okay. This is the line CTs, P1 focusing on the bus. Focusing on the bus. So P1 should be towards the bus. In the bus coupler also same. Bus coupler here in this project we it's represented two CTs not required. Only one CT is required. You can put P1 P2 on either because it is connected to two buses, right? So two buses you can place P1 P2 on wherever you want. And if you see here, I told that this P2 is connecting to this P1. But what I told, P1 should be here, P2 should be here. And for this CT, P1, P2 should be here, P1 should be here. Why it is different? Because I am protecting this bus from this CT. I will clear this in the protection chapter team. So this bus bar is protecting by this CT. And this bus bar, upper side of the bus bar is protecting by this CT. So the total zone was covered here. The zone is covered. Suppose if I place P1 like this, P2 like this, and this also P1 like this, P2 like this. So it is protecting this bus. It is protecting this bus. So this portion was left, which is not protected. To avoid this, I am taking the zone of this and I am taking the zone of this. So everything is coming under the protection. This I will clear in the protection chapter, the zones of protection. 89B, 57B confusing like D89B. Yes, let's come to down. Why confusing? Let's see. I am having two isolators. So to differentiate this, I am placing, generally this is D189. This is also D189. This is D157. To differentiate this, I am taking this one 89A and this is 89B. This earth switch is associated with this isolator. Means it is depending upon this isolator. Whether this isolator is opened, then this should be closed. When it is closed, this should be open. So for this, I am giving the same designation of 57A to this. Clear now? You can have A this, B this, or B this, A this, whatever it may, whatever.